Testing.
Thank you. Good afternoon, everyone. I'm delighted to welcome Dr. Andrew Bremer as the Bauman Lecturer today. Dr. Bremer is a board-certified internist, pediatrician, and pediatric endocrinologist, and also has a PhD in pharmacology. He was appointed the director of the NIH Office of Nutrition Research last year, just about a year ago. And before this, he was the chief of the Pediatric Growth and Nutrition Branch at the Eunice Kennedy Shriver National Institute for Child Health and Human Development, and a big champion for a lot of nutrition work, including a couple of training grants in the division, a long-standing maternal and child nutrition training grant, some of our work in human lactation, as well as the new training grant on artificial intelligence and precision nutrition. Drew has multiple roles. Other than NIH, he's also the co-executive secretary for the Federal Interagency Committee on Human Nutrition Research, the NIH champion for the Global Nutrition Coordination Plan, steering committee co-chair for the National Collaborative on Childhood Obesity Research, and the NIH liaison to the American Academy of Pediatrics Committee on Nutrition and Section on Obesity. He was one of the chief architects of the current NIH strategic plan for nutrition research from 2020 to 2030, which has precision nutrition as a big focus. In his current role, Drew is working collaboratively with different NIH institutes and centers to advance and coordinate nutrition research and participate in the development of new NIH funding initiatives and workshops. Thank you, Drew. Thank you for taking the time and visiting us, and welcome.
I'm all mic'd up. I can't wait. Can folks hear me? I'm not a podium kind of guy, but I want to thank Singham and Sarab and all of you, not just for being here today, but for what you do on a day-to-day basis. You know, if I leave with nothing, I want you to know that you have a friend and an advocate at the NIH, because what you do is super important. Whether undergraduate, graduates, postdoctoral faculty, it makes a huge difference, and it's such a joy to be your champion and your advocate. So today's gonna be fun. You know what, and in the audience is my roommate from college, because his son's a freshman here at Cornell. And this is my first visit. So Patrick, there you are. Yeah, but oh, Patrick has lots of stories. Unfortunately, all of which are true. But you know, but it also reinforces how resilient the human body is. But with that, also reinforces the importance of nutrition in many different ways. Because as you'll hear about, there's you know, my view of nutrition may be a little bit different than others, but I can't think of a better place to be than Cornell right now. Because I've had a wonderful morning. I met with food scientists, food systems experts, agricultural sciences, the human sciences, and all these are not siloed and not distinct, because they all work together. And that's a strength of Cornell that not many universities can say, is you have all this expertise right in the room. And how cool is that? And how cool is it to think about big picture problems and think about how you can make an impact that really can be a public health importance domestically, but also globally. So I often use the word nutrition is everyone's business, because everyone eats, and it's not just about the food we eat, but the biology of the food. So thank you for the opportunity to be here. I don't take it lightly, and it is truly an honor to be where I am. And I always like starting my talks with working the clicker correctly, or the button. But I always like starting my talks with giving recognition to the people who do the work, just as I'm indebted to everyone in the room for the work you do on the ground. I have a wonderful team, and I say that we're a team of 9 at the NIH. But we have a big footprint, and everyone on the office, you know, brings a different lens and brings a different view to nutrition, whether it be applied nutrition in the dietetic space, whether it be at the nutritional biochemistry, whether it be policy and advocacy in government. Everyone works together, because at the end of the day, I know I'm doing my job if we can support you doing what you are trained to do and doing what you do so well. So I'm often asked about, gosh, how does the NIH work? And where, you know, Drew, this sounds great. You're in this office. Where does it sit? So just, I thought I would take a an NIH 101, just to kind of put things in perspective. I had we had the privilege as of 2 years ago of being in office in the office of the director. Okay, what does that mean? So my charge from the NIH leadership is, Drew, we recognize now, long overdue maybe, the import and cross-cutting nature of nutrition. Let's coordinate science, and let's not be siloed, but let's coordinate science, nutrition science across the NIH, such that it's not just about the disease that the nutrition may be impacting, but about the biology. And so this is alphabet soup up here, but my job is really to help to interact with all the directors of all the different institutes and centers, and think about how we can think about nutrition science in a way that's holistic. And that's great. And I also have the privilege of working with many, many, many federal partners. Cornell is a beautiful example of how different federal agencies work together. And there's a strong USDA presence on campus. There's a strong NIH presence. And again, part of my job is to not be duplicative in efforts and not be overlapping, but to say, how do we think about nutrition science from a food production lens, maybe a health lens, from an implementation science lens, and how can we bring all those elements together? Because even in my conversations this morning, which have been fantastic, our discussions have ranged from very molecular and very basic science, which nerds like me love. Let's talk about mechanism. I love it. But then what's the public health impact? And how do we go from mechanism to public health impact and on a global scale? Those are very different areas of science. And that's where, again, the extraordinary breadth of what's happening, what you have here at Cornell is truly a blessing to think about science holistically. And then we also have the opportunity, as was mentioned, of looking beyond the governments. And again, two agencies that we work very closely with are the Gates Foundation and other organizations that are focused on obesity, and not to conflate obesity with nutrition, but what are some pressing public health issues? And so I love what I do, and I get up every morning just super jazzed to go to work, because we have the opportunity to play matchmaker and to think about science a little bit out of the weeds, but also knowing that we have experts in the room, all of you, who are in the weeds, that we can tap on and engage with. And if Saurav had a nickel for every time I asked him a question or paid him, he'd be a rich man in Hawaii right now. And so we recognize the extraordinary academic wealth at our universities that we support, and we don't take that lightly. So when I started the office, it has been just a year ago last week. We huddled the group, and I said, what is our mission? Nutrition science is a word that it's used a lot. It means different things to different people. How can our office make a difference? And this is a super long mission statement with lots of adjectives. I won't kill you by reading it, but there's certain words here that are super important. Evidence-based, and Saurav mentioned my passion about maternal child health and health throughout the lifespan. Super important, but equitable. I like to think we don't look at nutrition just from an equity lens. We have an equity vision. How to make nutrition context specific. This is not a one size fits all. I'm going to spend some time today talking about the Nutrition for Precision Health program and how it really looks at inter-individual and intra-individual variability and how context matters. We are not static creatures. Humans are biological systems that interact with our environment, and that matters. Culturally appropriate. Man, when we think about how to implement the science you're doing in a way that's going to make public health impact, if you don't meet the users where they are, that's a missed opportunity. Resiliency and sustainability. How can we think about nutrition science in a way that's not just focused on 2024, but but generations down the road? People ask me what's one of my drivers. I have to say, my daughter. And when I had a daughter, my life changed. And so I think about not just the here and now, but I think about, gosh, I want her to be healthy. I want her children to be healthy. I want her to have a sustainable food system, which we'll talk about. And that's where you all come in, because you can make it happen. How do we think about down the road and think about when we have recommendations for dietary guidelines or food productions or food systems, how that interacts with the environment and sustainability? So that, again, a lot of adjectives, but when I tried these other two versions to keep it short and simple, And then they sound good, but they don't capture all the elements of everything that I would love our office to be known for as we move forward. So what are some of our guiding principles? And this is, I'm a physician by training. So who knows what are the recommended number of hours of training that MDs are supposed to get here in the US? Anyone have a guess? 25 hours. Less than 1% of MD curriculum is based on nutrition. And most schools don't even achieve that. And when we think about nutrition, typically we're taught the board questions. I always, I always was a kid to my students. I have a hard time believing that the purpose of vitamin C is to prevent scurvy. I think vitamin C has other biological roles. The board question is preventing scurvy, and what happens when you have dietary deficiencies of micronutrients. But it doesn't encompass the world we live in today. That it is a very different world back 20, 30 years ago. So I liken nutrition and nutrition science to encompass the entire spectrum: food production, food science. Many of you in the room today are food scientists. That's so important. But then what happens biologically after the food gets ingested? What is the function of the food? What's the biology? And how does that affect health outcomes? This entire spectrum is what I want our office to really focus on. I make the case to NIH leadership and to others that nutrition touches every cell and every system at every age and stage throughout the lifespan. Give me a biological process that doesn't involve a nutrient. Super hard. And it's not just siloed nutrients. And again, we live in this era now of the food systems and dietary patterns, but every aspect of biology relies on nutrition. So if you ever have any doubts of the import of the work that you do, just think of this. Every cell, every system, every age and stage of life relies on nutrition. You'll hear me say a couple times through this talk today that I think nutrition is a fundamental biological variable in science. When we think about, again, characteristics that are relevant to every part of biology, we think about age, we think about sex. You think of that table 1 in your article that has the demographics and just kind of the breakdown, if you will. Nutrition is huge, and understanding nutritional status is quite relevant to how studies are designed, but also really important to how studies and science is interpreted, because it's an interpretation of the science that then may impact programs and policies. Nutrition is everyone's business. Why? Again, we all eat, and how we eat directly impacts our health. And I often use the phrase, food is a major thread in the interwoven tapestry of culture, tradition, history, family, and memory. It is a part of us, and so it's everyone's business. And unfortunately, we're at a state now where malnutrition at a global level is the leading cause of morbidity and mortality. Hands down, malnutrition and suboptimal diets are the highest risk factor for morbidity and mortality, more so than tobacco smoking, more so than air pollution, more so than high blood pressure. All those modifiable factors, diet surpasses them all. And if we were to address and if we were to stop hunger today, and this is something that when I speak in places, if we were to end hunger, and nutrition and food security is still a major issue, but if we were to stop, if we solve that issue today, we would not make a dent in malnutrition. And so that's an important concept. It's not food production and food availability is huge, but what is the biology of that food and how is that impacting health? At the NIH, as many of you know, it's very sometimes siloed and based on disease processes and based on outcomes. There's the National Cancer Institute, the Diabetes Institute, the heart, lung, blood. It's categorized based on systems which aren't very holistic or comprehensive. But again, nutrition touches them all. And so if you ever think that what you're doing is not relevant to biology at large, please think again. It's extraordinarily relevant. And then as I'll touch on in a second, I like ending by that nutrition it's important for my family, for your families, our societies, and the planet. And I won't spend a lot of time talking about sustainability, but the interplay and the interconnectedness of food systems in particular with planetary health is extraordinarily important. And so as Patrick can attest to, I'm a pretty simplistic dude. So when I try to have a conceptual framework that I can convey to others, I'm pretty simplistic, but I can draw a triangle. I did the bidirectional arrows to really to reinforce that when we think about science, and Cornell's perfect, food systems, you all have it covered. Every element of the food system is happening here at Cornell. But what that does and what the science does, it undoubtedly impacts human health, but it also undoubtedly impacts climate and changes. And for a long time, those arrows have not been bidirectional. It's been a question of how does the environment affect the food systems that affects the health. It's been very linear, and quite contrary. These are all interdependent and reciprocal relationships. And I think thinking about that with that vision and lens lends itself to asking different types of scientific questions, which from a sustainability standpoint are so important. Okay, so why do I care so much? Open up any newspaper. We are in the midst of an urgent nutrition-related health crisis. We may choose not to accept that, but that is the reality. And it's the second bullet point, again, depending on the audience, suboptimal diets. I talked about malnutrition, but here in the US, suboptimal diets is not like, impacting our public health and crippling our economy. It is dramatically affecting our national security. Now, when I talk to the armed forces about this, when I talk about, public health and the economy, they're like, oh, we're the armed forces, we have lots of money. But when I say, gosh, do you realize that nearly 8 in 10 young adults in the US today cannot qualify for military service because of a diet-related disease? And they're like, ooh, that doesn't sound so good. And when I say, gosh, do you realize that 11% of kiddos, youth, who want to join the Army are not qualified to because of overweight? And of the recruits that are disqualified, diet-related conditions contribute to 44% of those who are disqualified. They're like, ooh, that doesn't sound so good. So it hits every aspect of society. And then the magnitude of deaths, diet-related diseases, to put in context, 15,000 deaths per week are attributed to suboptimal diet. 15,000 deaths per week. 16,000 cases of diagnosis of diabetes per week. 1,500 new diagnoses of cancer per week. That adds up, and that's important. Again, if you ever doubt the relevance of what you're doing, think of those numbers. The economy, and this is when talking to Congress, I'm gonna grab my water. Sometimes they get freaked out about this. $1.1 trillion, spent on potentially preventable diet-related diseases. That's a good chunk of change. Again, I mentioned the risk factors, and then if nothing else, just to put some context in this, when I mentioned that on an annual basis, as many Americans, if not more, die from diet-related diseases, and I don't mean to be all doom and gloom, but just to put some framework, as died during the entire American Civil War and World War II combined. That's a lot of people. And so again, if you're ever concerned about the impact of what you're doing, please think again. Okay, so who here has ever read the Start With Why or Simon Sinek? I'm a big Simon Sinek fan, because when I go to work every day, I challenge all of us. Why are we here? What is your driver? Well, why did you want to join the office? Why do you want to stay in the office? As Patrick will allude to, I'm kind of nutty, so it's not me. What is our vision? What's our why? And I'll read. You can read it here, but it really is to stimulate and support actionable research that's solution oriented. And I'm going to pause here for a second, because that's not to negate all the basic mechanistic work that happens on this campus and happens elsewhere, because that is super important, because it is that mechanistic and basic science support that then informs how that's translated into something actionable. And that's what the NIH is really good at. They're very good at they're very good at the mechanistic question. So here I come in the office and say, gosh, that's awesome. I don't want to duplicate what you're doing. You guys are super good at that. So how can we take that fundamental knowledge and take that basic information and then translate it into something that could be scalable and actionable to actually make a difference? And then they're like, well, that's all great, Drew. That sounds great. How are you going to do that? And how are you going to do that on your budget? Like, good question. So I think fundamentally, as I try to, again, I'm a pretty simple dude. When I think about what are some of the opportunities to move the field forward, this issue of precision, and again, I'm gonna pivot in a few minutes to the MPH program that Cornell is totally integrated and which I'm indebted for, is how do we increase precision in nutrition science? How do we, because with that comes increased rigor and reproducibility. And when we think about science that's going to be defendable and science that's rigorous and robust, that's an element that, quite frankly, historically in the nutrition sciences has been missing. You know, where is the reproducibility? We have, and again, I preach to the choir. Oftentimes, there's so much information in the literature about dietary effects on health, what's good, what's bad, what's trendy, what's not. And so one of the ways to address that is to really enhance rigor in the science. And this is where the innovations and the crosstalk of all the scientific disciplines comes into play. Because in order to do this, we need to think outside the box. And how can we integrate all the scientific advances? And I'm not going to date myself, but back in the day, there was these siloed approaches to nutrition that missed the opportunity to integrate big data, machine learning, artificial intelligence, all these things that you are awesome at. And how can we all think about science together with that goal in mind? Because if we increase rigor and reproducibility, then we can be a little bit more confident in how that science can drive programs and policies. And so I have adopted this language of a nutritional household, and people are like, Drew, what the heck is that? And I'm like, well, again, I'm simplistic, but I am a firm believer that when we think about the biology of nutrition, it has to be, in my humble, I think we will move the field forward, collectively, and if we think about nutrition in the context of how people live. Humans are complex biological systems. We're all different, and we have our own genetic kind of internal biology that's very dynamic. Again, as a pediatrician and internist, I love it because I can see health throughout the lifespan. But we have our genetics, we have our microbiome that fluctuates. We have our developmental stage. We have a host of things internally that are impacted and impact nutritional status. And then we live in a real world. We don't live in our basements except during COVID. We have exposures. We do different things. We go to schools. We have communities, and all those exposures and environmental inputs really do affect someone's nutritional status. And fortunately, we're in a space now where nutrition is going beyond this reductionist approach of what does each individual micronutrient or macronutrient do, to really think about what do foods do. I mean, that basic understanding has been critical in the field of biofortification, and again, in our food scientists, how do we design foods and produce foods that can meet needs in the public health sector and global sector. But the reality is we eat foods. We don't sit down at the dinner plate and eat vitamin D and zinc and calcium. We eat our dinner. And so thinking about nutrition, not from a reductionist standpoint, but from a holistic standpoint, realizing that there's a lot of bioactives and a lot of things that are in food that affect our health and biology. And then using this to, again, just think about nutrition differently. Think about it as a fundamental aspect of science. Because as we dive into the world of nutrition for precision health and food as medicine, which I'll get to, using this paradigm is I think extraordinarily important, because this paradigm helps explain inter-individual. It helps wrap your mind around why dietary exposures can have such disparate effects depending on who the individual is. And that's not noise in the system. That's actually biologically relevant and biologically, it's to be expected if one takes this kind of philosophical approach. And then we use these terms interchangeably sometimes. When I talk about nutritional status, and I had some great conversations this morning about how does one define that? What are the tools? Do we have point of care devices? Do we have laboratory values? Do we do skin fold? How does one do that in the clinic? It really, that's to be determined. But this concept of status is really what is the translational concepts and the operational measure of adequacy of the nutrition and the diet to support health. And that could be individualized and tailored to the individual. And so that, again, it's not one definition for everyone. It's hopefully will be a toolbox that can be used by basic scientists and implementation scientists and clinicians. But how does one, how does one wrap their head around someone's nutritional status in the context of their life? And then how can diet and be utilized, or how can food be utilized to optimize their health? So it's not just knowing what goes in the mouth. It really is understanding the entire biology and how that all plays together. So then our what? If we're going to finish the golden circles, we've heard the word before, translation. That's our office is completely focused on the applicability and moving basic discovery, from discovery into the field. And I often will to tell people, I'm not interested in your publication. That's great, but I want to see that publication move into action. Again, our science should not end at the Cell paper or Nature paper. We do our community a disservice if that science ends on a shelf. Yes, that's good for promotions, and yes, that's good for academic advancement. And I'm not negating the importance of that. But then how do you take that science paper and say, gosh, what an awesome basic discovery. I'm going to get a lot of smart people together and talk about how do we translate that into something that can happen in the community. And what's cool about that is that then it's a great cycle, because then you learn when you implement things, and then it raises new hypotheses, and this keeps going. It's a self-generating action. And a couple of slides I'll mention. Another really fun part of the job is interacting with the government. And about 2 weeks ago, the President's Council on Advisors on Science and Technology published a report about nutrition science. Recognizing the importance, long overdue, recognizing the importance of nutrition at a national level and at a departmental level and at a government level. And then how do you move it forward? And so this is another exciting part of the job, is thinking with the extramural community, the government community. How can we design a program that can move the science forward in a way that, again, translates discovery into action? And then again, by increasing the rigor and reproducibility of the science, that just drives and reinforces the data that informs and the evidence base that informs policies and programs. Okay, our goals. For the sake of time, I'm not going to read them. They're kind of simple though. And I made this adjustment yesterday. Cornell, we think about kind of this circle that feeds on each other. It starts with the sciences, and it's nutrition scientists, it's the dietitian community. It's how do we think about what are the important scientific gaps? You guys are leaders in the space. It's been such a pleasure to support the T32 program. So when I'm at these discussions about budget and allocation, it's all sometimes doom and gloom, and it's a zero-sum game, and Congress is not going to support this. I reinforce, if you look at a return on investment, what better return on investment than training the next generation of our scientists and diversifying the field and enticing them and supporting them? It's not supporting them along the way, because that's when I say my driver is my daughter. I'm not, I'm just dad, and I'm not going to be the one that's solving all the problems. It's going to be you guys in the audience, and the future pipeline that are going to be the answers. So recognizing that and calling it out and supporting it is huge, because then that, again, it provides the evidence base. Because without the evidence base, when we talk to policymakers, we talk to government, talk to Congress, rightfully so, thank goodness, surprisingly, sometimes they say, what's the data? Now, sometimes when I hear that from Congress, I kind of giggle. I go, I'll tell you the data. Are you going to listen? But there is that importance of the evidence base. And then again, that drives clinical care, and that's a cycle that keeps going, which is fantastic. So again, for time, I want you all to know that I'm an open door, and if what I don't want is the NIH to be a black box. Because when I talk to my team, I say, there are 3 pillars that we have. We provide service. We provide our technical assistance, maybe, or if I can't, I find the right person who can. And we coordinate, and that's across government, across all sectors, because the work you do is so important. My job is to do all I can to support you in the field. Okay, so I'm going to pivot a little bit. As it was mentioned, I did take over the office a year ago. And the first thing I want to do is huddle all the troops and say, there are a lot of operational aspects and administrative aspects of the office, but what's the science? What are the areas of science that we think is important? And I've touched on all of these, but it just to reinforce, all three of these aspects, fall in our mission, and I think are super important. We talked about precision. Now, how to do that? That's when I'm going to, don't be surprised if you get a phone call from me saying, hey, can you come to DC or hop on a Zoom? Can we talk about this? I'm not the brightest bulb in the box, and I don't have all the answers, but I would like to think I know when to call a friend when I need to. So this is where, again, interacting with all of you and really reinforcing that it's a collective effort that we can make headway is super important. And we're not just in an ivory tower pontificating. We need your help. Lifespan, again, I have a bias, if you will, maternal child health, but I also took care of the elderly in clinical practice, and I have aging parents, so I see the spectrum. And what's cool about what I've enjoyed about clinical medicine is that kiddos grow up to be adolescents, to be a little snarky. They go through puberty, they often get pregnant, and then they get, there are these life stages. And defining optimal nutrition throughout the life course is challenging. And I'll pivot a little bit, and since Rob has been integral in all this, adolescent health, this is a segue, has been an area that really has been understudied. And again, if you ever doubt the importance of the work you do, in 2020, when all the schools closed down for COVID, if 400 million kiddos, think about it, here in the US, 30 million, globally 400 million kiddos lost access to their school meal. In many countries, that was their only nutritious food that they had access to. Whoa, 400 kiddos, almost, boom, one weekend, WHO makes the declaration, schools close down, the whole world is crippled. And 400 million of our youth globally are now, what do I do? And what's the impact of that? How does one assess that? What are the needs? How do we use the resources we have to optimize health in this global population? Again, the work you do helps answer those questions, because that's the magnitude of the work you do. It is so impactful. And then the environment. So I've touched on that, and then I want to hit training again, to call it out. We talk about the importance of training. One of my missions at the NIH is to stop talking about it and actually support doing it. So it's great to mention that we have programs, but we really want to again move that into action. So where are we going? The strategic plan was mentioned. Precision nutrition is a big element of the 2020 to 2030 strategic plan for NIH nutrition research. I will pause by saying this is research across the entire NIH. So all the institutes and centers are aligning their efforts in many ways to be a part of the plan. Hopefully in about 2 months, we'll have a report out that really kind of shows where we are and what the investments are, what the portfolios are, and what each institute is doing in that space. Another huge element is the Nutrition for Precision Health program. Again, I'll talk more about that. This is scientific discovery that's going to change how nutrition is considered. And Cornell is right in the middle of it. And I couldn't be more grateful for our colleagues, because this is discovery science that's, again, utilizing all these technologies, machine learning, AI, deep phenotyping, and really asking the question, how can we not just explain variability, but how can we use big data? How can we use emerging science to answer, not just ask the question, but hopefully to answer the question in an iterative fashion, so that we as practitioners can be more educated about how we inform nutrition recommendations, if you will, in the field. And then the other issue that comes up a lot is food as medicine. I'll touch on that. I'm going to get highlights to Rob and his team for a paper that just came out Saturday, kind of integrating all the efforts here at Cornell and how they all fit together. It's not siloed; they're all synergistic. And then with a lot of the discussions I had this morning, the issue about food regulation, and when we think about scalability, dissemination, how do we educate the community? We work a lot with our regulators, and so a big part of what I like to do is to be working synergistically with the FDA and others about as new foods are introduced or in the market. How can we think about foods both from a production standpoint? In 2050, this planet will be host to 10 billion people. and we need to feed them. That's where you all come in. And then the question is, how can we feed them in a way that has a health lens as well? So how do we use just the tremendous innovations in food science, and how can we think about those innovations in a way that has a health lens? How can those foods have healthy consequences and healthy outcomes versus potentially unintended deleterious consequences? Right. And with that, these efforts are in line with the current administration's support of nutrition. And I do want to highlight that the Biden-Harris administration has been very supportive of efforts in this space, because from their constituents, they do realize that there's a problem. Then the question is, how do you solve the problem? And that's where they've asked our inputs. And then I quickly say, I'm going to ask you guys, because you're smarter than I am. And then I mentioned again the currents, not just from a government standpoint, but advisors to the government have really, again, just recently said there's a problem here, but there's also an opportunity. And what are our resources, at a federal level, to really tackle this problem intentionally, and not just do one-offs, and not just have a haphazard approach to nutrition, but how can it all be coordinated, and how can all the disciplines be merged so it makes sense? Okay, so this is something that I hope everyone is in the room at least has heard of, because again, Cornell is front and center. Now 2 years ago now, we launched on this ambitious project, Nutrition for Precision Health. How do we take these concepts and how do we get them to a subpopulation or population level or individual level? And this, I'll skip some of the slides for sake of time. But we really had three basic pillars. Again, in this utilizing this concept of an ecology, we realize people are people. And so a big part of this study is meeting people where they are and say, okay, this is important. If we can get in, I'll show you the end in a minute. If we can take 8,000 plus people, individuals who we can do some phenotyping and then collect data on, can we use that information to make sense of what happens in real life when individuals are eating diets, and what is their response? And then can we take that a step further and can we have some test diets where again we do a little deeper dive, again in the community setting where people are living their lives, and can we and I'll show you the outline in a little bit as far as the operations aspect, and then can we go a step further, and can we bring people in-house in domiciled facilities? And when I was at UC Davis, I was the study physician on many domicile studies, and it's great. It's not necessarily reflective of real life, but you can do some great deep phenotyping. I mean, talk about a controlled environment. So you can control everything and really get a good sense of what the biology is. So we ambitiously, with Sarah's help and others, said that let's think about this and how can we do this? And it has many moving parts. But again, I want to just call out Cornell. Since the inception of this program, you all have, whether you know it or not, have been front and center in how we think about not just study design and what research questions could be asked, but as importantly, how do we coordinate everything? And then what's really important is how do we think about how are we going to interpret the data? That next step, what's coming down the pike, and how can we interpret that data? And so by way of quick background for those. Has anyone not heard of the All of Us Research Program? Here's my plug for the program. This was a spin on, there was a big push by the Obama administration to really think about a U.S. representative sampling of individuals to collect data. And so the All of Us program was accepted to be hopefully 1 million individuals. Really a platform to collect a lot of data and in a diverse population, where we can start asking in-depth questions that require the magnitude of size to do. And so this has been ongoing now for several years. I'm happy to say that even despite budgetary cuts, this is now being rolled out in the pediatric population as well. For many years, it was 18 and above. So putting on my pediatrician cap, I say, well, it's not really all of us. It's some of us, but now I'm happy to say it is all of us. It's capturing the population to build, to build data sets that then can be used to catalyze and stimulate stimulate research questions with the end goal being health. And so when we thought about nutrition for precision health, like, what an awesome platform, and what a way to be fiscally responsible. Because we now have a national investment. So again, hopefully a million or so individuals, where we're collecting all this metadata. How can we think about nutrition in this space? And so hence the inception of MPH. It's in line with our strategic plan. It utilizes the All of Us research program. It is the largest national investment in nutrition, and I was stoked. If you think about the investments in nutrition science, the stats will say 4 to 5% of the NIH budget is dedicated to nutrition science. And then when I say that, people in the room like this, like, oh my God, that's it. When you think about cancer, think about other elements of health. Not even 5% of the NIH budget is focused on nutrition, but yet nutrition touches every other aspect of health. I would love under my tenure for that to change. I am ever the optimist, but that, I'm proud to say that this is the largest national investment. And again, Cornell is one of the sites, and the modification, my little smiley face there, and you all on this campus have been instrumental. This is just a representation of where the clinical sites are to represent the US. But again, I just want to say thank you for those of you involved in the program. Just a tremendous amount of gratitude. And what are our goals? Again, a comprehensive set. And when I say phenotyping, we're just not doing blood samples and doing questionnaires. This is a really complicated protocol. And what's been great is because of the individuals who are running it. The number of participants who want to come actually outnumber our ability to accommodate, which has been fantastic. So it's been one of the few studies where people are chomping at the bit to be a part of this, because on the back end, those individuals, granted there may be a selection bias because they want to be in research, but their question is, what's this mean to me? And one of the goals of this program is to say, what? We hope that your participation in this program will let us, when we do the data analysis and we do the analytics, our goal is to be able to say, this is what it means to you. Drew, you're a 52-year-old dude and you live in Bethesda and you're kind of active, maybe a little bit, you lose some weight, but this, based on your profile, based on your genetics, based on your experiences, based on your exposures, this may be a dietary pattern that may optimize your health. And that's going to be very different than my daughters, than her girlfriends, than her girlfriend's moms. So again, doing that discovery science is paramount, but this is important. I can't stress it enough. When this program was incepted, it was not just to generate a database and have publications. It was, again, how to use the data to be meaningful and informative. And so this is kind of, again, a breakdown where we are shooting for more than 8,000 people. If you think about nutrition studies, that's great. Again, and this is where I lean on people much smarter than I am, because when you get into this number and amount of metadata and big data and omics and all these things that we talk about, and we use these terms, how do you use that data to make inferences and to make meaningful decisions? That's where I'm the first to say, I don't know, but I know some really smart people who do. And they may be in disciplines that traditionally have not been thought of as being relevant to nutrition. Is our engineers, is our bioinformatics, our mathematicians, our statisticians, fields that historically may not have thought to be relevant to nutrition. Gosh, they're more relevant than ever, because when we ask these complicated questions, we need them, and we need everyone at the table. And that's so everyone. Another theme is that at the ONR, at my office's table, there's a seat for everyone. I can guarantee you, no matter what area of science you do, give me 30 seconds and I'll put a nutrition spin on it, because that's how relevant it is. There's no irrelevant science when it comes to nutrition. And just so everyone's kind of on board with what this program is doing, because this is happening in real time right now. The observational part of the program is looking at, again, over 8,000 individuals. This is a relatively low lift, and then we do follow people for a 10-day period of time. We do lots of assessments, and then we do challenge tests at the end. And this is only possible because Saurabh and the coordinating center can keep us all organized. And then we're gonna do the analytics and again with the goal of really generating some platforms and some algorithms that can help inform choices. Doing a little deeper dive, this is when we start testing diets. And I want to be clear, look at the clock just to make sure I stay on time. Yeah, what we're not in the business of is testing diet, testing the Mediterranean diet versus the Ornish diet versus, because that's not our goal here, is to declare a winner or a loser or what diet is good or bad. Because quite frankly, that's going to depend on who the person is. And so doing the discovery science, learning how individuals respond to food and health outcomes, the nutrition, that's what's going to drive the decision of what diet is quote unquote good or bad. And I think that's where been a limitation in the field, is that there's been lots of diet A versus diet B looking at efficacy outcomes versus the biology outcomes. And again, just for the sake of completeness, and this is when three diets, individuals are exposed to these diets, and they're getting lots of assessments. So we're doing some deep phenotyping that often in your R01 grants for other studies is not feasible to do. And then we're taking it one step further and saying, this is great, thanks for playing. Do you want to live with do you want to come to the hospital for a month and hang out? Because you can watch lots of movies. But we bring people in and again, expose them to different diets and then really do a deep dive. And this is where the fundamental biology comes in. So for those of you in the laboratory who are working on micronutrient A or micronutrient B, that is super important because doing the deep phenotypic dive is when you can link all that information you're doing in the laboratory and actually link it to a health outcome, which may not always be apparent when you're doing the basic biochemistry. But again, it's all connected. And so people always ask me about the diets. I'll make sure you all have access to these slides. But I mean, everyone's heard of the blue, purple, and orange diet, right? Again, we intentionally designed the study not to be responsive to kind of fad diets or diets that are out in the public right now, but to ask the question, how do people respond to dietary patterns? Because at the end of the day, what we want to do is make a relevance. When we make recommendations to our individual families and people, it's not a one size fits all. Right? It's not this diet is best for everyone. It's really to say, gosh, based on your characteristics and based on your health status, based on your genetics, based on your microbiome, based on where you live, this may be a more relevant dietary pattern for you to meet you where you want your health outcomes to be. And then again, this is where the implementation part of this is to engage the end user to what their goals are. Okay, and this is just a timeline. Our goal is to finish in 2027. Again, this is where the coordinating center and all of our centers are hugely helpful. I'm the first to say that what I don't like about the slide is that this implies it's over. This is just the start. This is discovery science. And I'm totally going to steal something that Sarab, as we were walking over this morning, said, this is, there's precision nutrition 1.0 and then 2.0. This is teeing us up for precision nutrition 3.0, taking this data, developing algorithms, making it clinically applicable to then go into the field and start validating and start testing whether the information that we've learned from this is having beneficial health outcomes and a clinical impact. And again, literally all of us do have access to this data, no pun intended. But it was also always intended to be a platform where researchers have access based on various tiers to information. And this goes back full circle to the training and the next generation. Because again, we don't want this, it would be a failure if we just publish this information and it's sat on the shelf. What we want is to have this information available to smart people like yourselves to then interrogate it, ask new hypotheses, form new questions, and then test that. So from its inception, this is meant to be a platform and a resource to stimulate new research when all the data are available. Okay, so I'm going to pivot now to we've heard about the precision nutrition and the relevance. Nutrition requires it's not one size fits all. It's individuals vary. What's exciting is that now people are talking about it and people want it and consumers are demanding it. And there's a lot in the private sector about nutrition and precision nutrition and what should I eat for my health, and you can send it a poop sample and you get an analysis. But what we want to do again is be comprehensive in our approach to when we educate the end user and our participants. How can we do it in a way that's again that can be most impactful? And that's what I'll end on is again we want to maximize impact, and these are all scientific areas that will do that. And again, one of the joys of coming to my 4 hours of conversation this morning, so many different areas of science represented on this campus, where again, the engagement was fantastic. And when we think about what the impact can be of working together and asking cross-disciplinary questions, it really is great. And again, I challenge anyone, no matter what science you do, it matters to nutrition and it's relevant to nutrition because nutrition touches every aspect of biology. And this is where, again, I'm not the brightest bulb in the box, but when we talk about machine learning and AI and all these emerging technologies, they are going to drive a revolutionary aspect of science that in my textbooks 30 years ago, these types of graphs were much simpler. It was food you eat, they showed a picture of the stomach, maybe a piece of poop, and then you had a health outcome. But there's so much more than that is involved in nutrition. And so again, another take home is that when you leave here today, think, don't put any boundaries on what your science can do, because it plays into this equation, and it's super important. And it's not just important individually. The advancements in precision nutrition will touch every aspect of society, whether you know it or not. It's micro level up to macro level, and all that is extraordinarily important. And again, your science matters. And before I pivot to the last slides, what you do is not just limited to this country or this hemisphere. We are in a global society, and there's bidirectional learning. And so studies that are being done in India are extraordinarily relevant to the population of Baltimore. We are in a global economy now, in a global situation where in this space of food and nutrition, lessons learned anywhere in the world are applicable at a global scale. And you guys are a part of the solution, which is fantastic. So I'm going to embarrass Rob. As I was packing up Saturday, I was going through my news feed, and I was like, oh, I saw this paper, and like, this is fantastic. I think about this every day. And I'm like, wow, it's the Cornell group. So I was like, again, you guys are front and center in this. And I'm totally going to steal these figures. It puts a nice perspective when people think about, again, this concept of precision nutrition and how that can be implemented, again, how that can be translated. And I'm going to use the food as medicine paradigm, because that's a paradigm that goes from very tailored interventions to public health interventions. What we learn from the science you're doing and the science that's ongoing in MPH, the science you're doing in your laboratory, that all feeds into this data system with our computer scientists, with our mathematicians, with our statisticians. The collective we, because I'm not smart enough, but then there can be algorithms and there can be outputs that then can be implemented to the individuals on the back end. So it is this nice continuum of basic scientific discovery through implementation science and then global health. What a cool paradigm. And it's all driven by the science. So it's credible, it's rigorous, and it's based on data and not just based on opinion. One of Nancy Pelosi's quotes I often use is that she said, data is not the plural of anecdote. It actually is driven on science, and that informs programs and policies. So this is, I think, my penultimate slide. I was in the academic sector for a number of years, and I loved it. What changed my output and how I thought about science was my daughter, and so I came to government 11 years ago, and it's been wonderful. But it takes all these sectors working together. And so the other theme I want you to think about when we leave here today is that no matter what career path that you're in, private sector, we talked a lot about the food scientists being in the private sector, that's important. Academics, hugely important, because it's going to take a village to then address a lot of these public health issues. And in a way that is done in a coordinated fashion, in a systematic fashion in a way that has the most impact. So this is my self-serving slide. You know, I love hearing from you, and I, one of my goals for our office is to be accessible, to be available. As I mentioned many today, if there's questions about the NIH and where we are, what our priorities are, where we're going, what our vision is, call me. I don't want anyone to leave today thinking that we're a black box that sits in Bethesda and that we're not accessible. It's because quite to the contrary, I'm not doing my job if I'm not helping you do your jobs. And so it's very synergistic. And with that, I do want to say thank you for your time. I went a little bit over and I apologize. Not a day goes by that I'm not grateful for the opportunities I have, and I have been super blessed. But I also recognize that that's, that only happens because I have the opportunity to work with great people, and including yourselves. And that's, when we think about these big challenges, big public health challenges, again, nothing you do is so small it doesn't matter. I dare say everything you do matters. And part of my job is to have the joy of making those connections and facilitating these systems. Because at the end of the day, I go to work because of the mission. I think, in academics, people go to work. Sometimes the mission can be obscured by the realities, and just life's hard. But at the end of the day, I go to bed at night saying, "Gosh, I love what I do because I hope it makes a difference, both in our lifetime and also lifetimes to come." And so that I'll be quiet. But thank you for your time and attention. Right. Do you have time for questions?
Questions, very interesting.
Interesting.
Really cool to see what on this one. So,
Oh, thank you.
it's our great pleasure to present you with this plaque.
Oh, good
Bauman
picture.
Lecture.
Thank you. Thank you. Hello, Patrick. Thank you.
I think it's an encrypted version of Bill Nye the Science Guy, actually. Thank you very much.
Thank you. Thank you.
There we go.
I love the wine business weekly around. There we go. There we go.
All right.
Yeah, happy to take questions.
Thank you again, Dr. Bremer, for
Oh. Anything's fair game.
Thank you so much. Hello. Thank you for the great lecture, Dr. Bremer. It's really cool to see there's a Office of Nutrition Research at NIH. I'm a PhD candidate in community nutrition, and it's just really fascinating to see the precision nutrition efforts. And I'm just kind of thinking, how do I incorporate precision nutrition in community nutrition? And especially when, for example, I'm thinking the second step of the All of Us study, where you might prescribe meals in their community. And I'm just thinking logistically, how do you do that? Because I work with communities of low income that are affected by poverty, and there are a lot of social demands that might be above nutrition, for example. So how do you, I guess my question is, how do you incorporate like the community specific factors, cultural, environmental factors when you're thinking about precision nutrition?
And thank you for that question, because that is at the crux of what we want to do, is the implementation aspect of these basic science, the discoveries. And so my dream and what totally jazzes me is using this information that we're obtaining, and then because of the diversity of the All of Us population, honing in on your questions. It's not just we recommend these dietary guidelines. The question is, how do you make it culturally appropriate, context specific, and relevant to the population that you want to serve? And so part of the rationale for such the large N of this program is to try to capture those elements. And so when we ask our dietitians or ask our healthcare providers, particularly those in the field, particularly those in underserved communities, and for those of you who aren't aware, diet-related diseases. You ever want a poster child for for a process that exacerbates health disparities, diet-related diseases are one of them. Because they disproportionately impact those from lower educational attainment, lower income, rural communities, tribal reservations. So that's where the disease burden is. So that's where we want these algorithms and want the interventions to be most relevant. And having some cultural humility is extraordinarily important, because that's been a shortfall in modern medicine. And I can talk about the amazing and important role of the dietitians for weeks. How to take that information and make it relevant and applicable to the population that you're trying to serve. I think that the information that's going to be gleaned from this program will actually provide data to those providers that again, as they interact and mingle and learn the communities that they're serving, they have more tools in their toolbox to tailor interventions that are going to be relevant, both from a health standpoint, but from a cultural standpoint. Because it's very easy for me to tell people, to go to a community and say, eat more fruits and vegetables, and they're like, yeah, but there's no access. There's no access. I don't like that stuff. I mean, so how to engage the community in a way that meets them where they are. And right now we just don't have those tools. And so my goal of this precision nutrition paradigm is really to have the data to generate those tools, so those individuals who are in the field have some guidance on how to meet individuals where they are. Because right now it still is a one size fits all, and we know that's not how life really is. But thank you for the question, because that goes to the crux. I said I don't want to be a broken record. If the research ends at discovery, we have not done our job. It has to be translatable to the public.
Hi, very nice talk. I was wondering, thinking about all the problems, challenges, potential solutions with kind of getting to a point where everyone has kind of adequate nutrition and access to it. If you could change like one thing right now that gets us like a big part of the way there, what do you think that would be? Or is it too complex of a problem?
Thank you for that. It is complex, but I'll give you an answer. You've been in government a long time when you can talk for an hour and give no answers. You're like, what? But I am going to answer it because I think the answer is embrace the complexity. Yeah, there's lots of layers. This is a multi-layered issue that again affects all of us. And historically, the way to deal with that has been, I don't want to deal with that. It's too hard. And I use microbiome, the gut microbiome as an exemplar of where we think we are now in nutrition. Again, not to date myself, in medical school and residency, we never talked about it. We talked about poop because I'm a pediatrician, and you can say fart jokes and poop jokes, and the kids love you. But we didn't appreciate the microbiome. And when that field started emerging, it was like, wow, this is just too complicated. It's too hard. But tools became developed, and cross-disciplinary teams emerged in that field now. And think about what it's done to the field of nutrition. So I think to answer your question, yeah, there are lots of elements, and when you think about it all together, it can be daunting. When you think about, gosh, we have scientists now, we have scientific innovations, and we have ways to address those issues. And it's not just in the laboratory. And one of the discussions we had this morning, we need to embrace our social scientists. We need to embrace our implementation scientists. We need to bring them to the table. We need the food scientists. We need all the disciplines at the table, because then it's not so daunting. Because then you can start parceling out, what are the questions to ask, and how is addressing one thing going to be impacting another, and how can all the everything be on the table and talked about. So my answer is, there's not just one thing, and if there was just one thing, we would have done it by now. It's lots of things, and it ranges from public policy and governments down to the community level, down to the school level. There's so many layers, but each layer in of itself is addressable. And I think again, the adage of it's just too hard, that is so non-satisfying, and it doesn't. It's like when I've done this for my daughter, just because, dude. We need more than that now. This is 2024. We we can address the complexity, and we have the tools now. This is where, again, I'm just a country doctor. I had the pleasure of taking care of individuals throughout the lifespan, and I'm not the brightest bulb in the box, but I know that the science is there. And so I know that there is the scientific innovations to be addressing these problems in a multifaceted way. And saying it's too hard just doesn't cut it anymore. Yeah, I can talk for hours.
Hello, my name is Amalia. I'm food science, but also a dietitian from Argentina. Great talk. Thank you so much. And I wonder, you didn't say much about it here, but the BMI, right, the Kitellex index, is now that we have so many tools for different approaches to evaluate if someone is normal weight, overweight, or underweight, is there a future that will not give us only that tool to assess how healthy a person is? Thank you.
Thank you for that question. And first, before I answer, I want to say thank you for your role as a dietitian. And that's when we think about nutrition science and clinical care. There's about one doc for every 250 people here in this country. One could argue that's good or bad. There's only one dietitian for every 3,000 individuals in this country. Think about that. And they're the ones with the boots on the ground. And so I thank you for your service. The body mass index, this is a 2-hour talk in and of itself, was designed and implemented to be an epidemiological tool. It is great. It's a great epidemiological tool. It was never incepted to be a diagnostic tool. To your question about other matrices, the answer is yes. The one that's getting a lot of press, even in the Times last week, was the body roundness index, which I don't love the terminology. The BRI. I'm like, wow, how round am I? I don't know. But there are other matrices that are being. There's a deep phenotypic assessment. So it's what's being done in NPH, or there's the intensive ways to assess body mass and assess lean mass and muscle mass and fat mass. But at a public health level and epidemiological level, there are recognitions of the limitations of BMI, and particularly how it's being used in clinical practice. So this body roundness index is a way to mathematically, again, in a way that you can use a calculator and do some measurements in the field that is better correlated with visceral fat versus subcutaneous fat and whatnot. So there are tools. Again, the question is what's the tool going to be used for? And I go back to the BMI was never intended to be a diagnostic tool. It was an epidemiological tool, and it's great at being a public health epidemiological tool. It's how the matrices are being utilized clinically.
Jeffrey, you want to challenge you on me? No, I think everybody wants good stories.
Yeah, he has good stories. Yeah.
Hi, I'm Yatin Shu. I'm MD PhD, and I would like to echo your phrase saying that food is medicine. Because in Chinese medicine, we always think the food is the medicine. Yeah, when I'm coughing, my father cooked a pear juice for me. But my question is there any promotion to enhance the nutrition as a course for the medical school? Because when I was in the medical school, I didn't learn so much, and until now, I really realize how important it is. Thank you.
The answer is yes. So we're past 11. So those of you who are online and who are buying airplane tickets or shopping or on Google while I was talking, at 11 a.m. this morning came off embargo a paper by David Eisenberg and his colleagues, and it's on JAMA Open Network as of 11 o'clock this morning. That did a deep dive into nutritional competencies and literacy in medical training, and I had the pleasure of reviewing some papers over the spring and wrote a commentary. Yeah, I could talk for hours on this too. It's super important because then it goes to the implementation. We can't expect, the physicians today, not because they don't want to know, in the curriculum, again, like I said, right now the ACGME standard is 24 hours, 25 hours during the 4 years. Less than 1% of time in medical school is devoted to nutrition. And yet the biggest burden on health outcomes are diet-related diseases. And so that's a huge mismatch. So then the question is, how do we train our medical staff? And not train them to be duplicative of the dietitian staff. Yeah, so how to synergize the education. But then importantly, who's going to teach them? When you look at the medical school, and this is where, again, a school like Tufts, a school like Cornell, and Tufts, that matter because of the way it's designed. You know, you guys have the resources right here. You have all the programs. Not that it's an easy fix because there's logistical issues, but in a lot of medical schools, they don't have the depth of nutrition sciences. So who is the teacher? And so those are all issues that are being worked through. Is how to, again, it's one thing is to say let's do this, but then how to operationalize that and how to make it happen. But it will change. And again, and places like Cornell are going to be leading the way to how to implement that, how to integrate nutrition science, and not just from a standpoint of nutritional biochemistry. I don't want to dismiss the importance of nutritional biochemistry. Again, my exposure to nutrition is, you know, what's the micronutrient deficiency and what's the disease? And if I can match those two together on a board exam, I'm good. Nothing about biology. And so, but now the question is, how do you learn about nutrition in a way that where you recognize that, yeah, that impacts biology, and then that impacts disease, and then that, to your food as medicine question, you are spot on. This is not a new paradigm. You know, it goes back to Hippocrates. Let food be thy medicine. You know, then how to use that paradigm then to make an intervention. That's informative. So then this is where and Sarab called it out in the paper, and again, Cornell has been very active in this space. When we think about improving health at a grand scale, we need to think about the field. We also need to support the education and how to do that. And that's where it takes thinking outside the box and being creative. But I do encourage everyone. David's paper came out again. It was embargoed until this morning, but it's one of the first deep dives, and it wasn't meant to call out a deficiency. It wasn't meant to be punitive and that we're doing a bad thing here. But the reality is that this is the current state of where we are, and if we really want to be intentional about making a public health impact, we need to change our paradigms and not be so constrained about how we think about medical education, that we recognize the importance of it. And again, not to be duplicative of other fields, but how do we all work together to achieve those outcomes? Yeah, thank you for that. Again, I could talk for hours on that because that's super important.
Okay, let's thank Joe one more time for his strong leadership and great passion for nutritional research, kind words to Cornell, and of course, outstanding lecture today.
Thank you.
Before we close, I'd like to also acknowledge the great help from professionals in Cornell, Bob and Erin and Erica and Jessica, Linda and Jackie and Sydney today to help, and also the committee to run the program. So now we turn to the next session. The graduate student you signed up for meeting with Joe will stay here, and we have a pizza. Okay. Cool. All right. Okay.
Thank you.
Well, great.
No, thank you.
I would think about it. I need to invite you to write a editorial for